Okay, in this video we're going to talk about voltage, and voltage is actually one of those concepts that's pretty hard to get, but you can get there. And so in the last video we talked about electric potential, which is V, also in units of volts, and it is the potential energy per charge. And we talked about, you can find the potential energy, but what if we just wanted to talk about it from like a location standpoint? Like, well, would a charge have more potential energy if it were at A or B? And A would always have more than B on a per charge basis. If we had a single charge, we put it at A, it'll have more potential energy than if we move that charge to B. The reason that we have electric potential is because that's always true. Electric potential is always higher in A than B, but the potential energy at B could be higher than A if we happen to place a really big charge there at B and a small charge at A. And this lets us talk about it on kind of a level playing field, I guess. And so once you think about electric potential, each point, A, B, and C in this case, has an electric potential, how much potential energy, a charge would have if we're there on a per charge basis, with bigger charges having more potential energy. Okay, so potential difference is voltage, the same thing, two words for the same thing. And the voltage is just the change in potential energy, right? Delta V, V is electric potential, so voltage is the change in potential energy as you go from A to B. And again, analogies with gravity work really well. If you drop a pencil, and you can think about this dropping a pencil, and the pencil drops from A to B, what was the change in potential energy versus from A to C? And again, from kind of an intuitive standpoint, you can see that the potential energy from A to C, the change is much greater, right? It lost a lot more potential energy as it went from A to C. And in terms of our voltage, I've written down three ways to look at it down here. Voltage is the amount of work per charge, right, done by the electric field as it moves from A to B. So again, you can think about that as how much work is done on a charge if it goes from A to B versus as it goes from A to C. You can also think about it as going the opposite way. How much work would I need to do against the electric force to go from C to A or from B to A? And again, you can see both ways are telling you the same thing, and they're talking about potential energy per charge. And the last way to think about it is, well, remember that if you're losing potential energy, it means you're gaining, we've been thinking about it as kinetic energy. And so if you go from A to B, how much energy do you gain, right? How much money do you get to draw out of your bank account versus going from A to C? And you can see that as the voltage increases, right, as the difference increases, the difference from A to C being higher. So we can say that VAB is less than the change in electric potential from A to C. And what that means is that from A to C, a charge will pick up more energy just because it's kind of like it's falling more, is a way to think about it. And so by increasing voltage, we're increasing the amount of energy a charge gains from going from one point to the other. That becomes important when we start talking about circuits. And in a circuit, if you increase the voltage, you're increasing the amount of energy that a charge gets as it goes from one point to another. And that energy ultimately ends up helping to power your appliances. So let's look at another example. Actually, one thing I should mention is that normally when we use that delta sign, we do final minus initial. That is not the case for voltage. For voltage, the voltage between A and B, right, or the potential difference between A and B, same thing, is really the electric potential of A minus the electric potential of B. That's just something to note here. And that's why what we've been doing makes sense, right? Because the drop in potential energy from A to C is higher than from A to B. And these are going to be positive numbers from A to B or A to C. Something to think about is, what if we went from C to B or C to A? Right? And now you would be doing work against the electric field, which means you're losing energy. You have to add energy to get there. And so that's how you can get a negative voltage. And all of this gets really confusing when we start thinking about electrons versus protons.